Hi all, it's me Anaka, all here to give you all an overview of digital signal processing. So let's get started. So as an introduction, I would like to say what is a signal. A signal can be a function of time, distance, position, temperature and pressure. It represents some variable of interest associated with the system. As an example, I would like to say in an electrical system, the associated signals are electric current and voltage. Whereas for a mechanical system, the associated signals may be force, speed, torque, etc. So the examples of signals we daily encounter are speech or music, picture, and video signals. A signal can be represented in a number of ways. Most of the signals that we come across are generated naturally, and some are generated synthetically. A signal carries information, and the objective of the signal processing is to extract the information. So, what actually a signal is? So, we should know that the signal processing is the method of extracting information from the signal, and it depends on the type of signal and the nature of information that it carries. So, signal processing is concerned with representing signals in mathematical terms and extracting the information by carrying out algorithmic operations on the signal. The signal is represented in mathematical terms and the information is extracted by carrying out algorithmic operations. Mathematically, a signal can be represented in terms of basic functions in the domain of the original independent variable, or it can be represented in terms of basic functions in a transform domain. The information contained in the signal can be extracted either in the original domain or in the transform domain. So, what is system? System is an integrated unit composed of interacting structures to perform a desired task. The task may vary such as filtering of a noise in a communication receiver, detection of range of a target in a radar system, etc. And its function is to process a given input sequence to generate an output sequence. So the DSP has a tremendous growth because its techniques are applied in almost every field. So let's take a look at the importance of DSP. Digital circuits do not depend on precise values of digital signals for their operation. They are less sensitive to changes in component values, temperature, aging, and other external parameters. In a digital processor, the signals and the system coefficients are represented by binary words, and this enables one to choose any accuracy by increasing or decreasing the number of bits in a binary word. DSP facilitates the sharing of a single processor among a number of signals by time sharing, thereby reducing processing cost per signal. Digital implementation of a system allow easy adjustment of processor characteristics during processing by changing the algorithm. While analog signals deteriorate as time enhances and cannot be recovered in its original form. The storage of the digital data, we should say, it is very easy. Now, let us look at the classification of signals. So based on their nature and characteristics in the time domain, signals are broadly classified as continuous time signals and discrete time signals. So let me explain what this really means and what exactly their difference is. A continuous time signal is a mathematically continuous function and the function is defined continuously in the time domain. On the other hand, a discrete time signal is specified only at a certain time instant. The amplitude of the discrete time signal between two time instants is just not defined. And these are further classified into four. That is, the deterministic and non-deterministic signals, periodic and aperiodic signals, even and odd signals, energy and power signals. So let me explain this in detail. First of all, deterministic and non-deterministic signals. Deterministic signals are functions that are completely specified in time. The nature and amplitude of such a signal at any time can be predicted, and the pattern of the signal is regular and can be characterized mathematically. Contrary to this, a non-deterministic signal is one whose occurrence is random in nature and the pattern is quite irregular. Next one, periodic and aperiodic signals. The definition is evident from its name itself. A continuous time signal is said to be periodic if it exhibits periodicity. It has a definite pattern that repeats over and over with a repetition period. A signal that doesn't have this property is said to be aperiodic. Now, the third one, even and odd signals. Even signals exhibits symmetry in the time domain and is identical to its reflection about the origin, whereas the odd signal exhibits antisymmetry and is not identical to its reflection about the origin and is negative. Now, the last one, energy and power signals. The energy signal is one which has finite energy and average power. The power signal is one which have finite average power and infinite energy. If the signal does not satisfy any of these two conditions, then it's neither an energy signal nor a power signal. Now, let's take a look at the classification of systems. Systems are broadly classified into continuous time systems and discrete time systems, which are further classified into five different forms. That is, static and dynamic systems, linear and nonlinear system, time variant and time invariant system, casual and non-casual system, stable and unstable systems. Now, I'll explain these in detail. First one, static and dynamic systems. The output of the static system at any specific time depends on the input at that particular time and does not depend on the past or future values of the input. The output of a dynamic system at any specified time depends on the inputs at that specific time. Such systems have memory or energy storage applications. Now, the linear and nonlinear systems. A linear system is one in which the principle of superposition holds. The response to the sum of the weighted inputs is same as the sum of the weighted responses. System that doesn't obey this is said to be nonlinear. Now the third one, time variant and time invariant systems. A time invariant system is one whose input-output relationship does not vary with time. Such a system is also called a fixed system. A system contrary to this is a time variant system. Now the fourth one, casual and non-casual systems. A casual system is non-anticipatory. The response of the casual system to an input does not depend on the future values of the input but depends only on the present or the past values of the input. If the response of the system to an input depends on the future values of the input, then the system is non-casual. Now the last one, stable and unstable systems. A system is said to be bounded input and bounded output stable if every bounded input produces a bounded output. So what is this bounded? What exactly means by the term bounded? A bounded signal has an amplitude that remains finite, and the output does not grow unreasonably large. The systems contrary to this are unstable. Now, I would like to explain in a brief manner what is the process, about the process of analog to digital conversion of signals. So, this has been briefly depicted in the figure which I have shown here. So, let's get into the process. A discrete time signal is defined by specifying its value only at discrete times called sampling instance. The sampled values are quantized and encoded. A digital signal is obtained. The digital signal can be obtained from the analog signal by using an analog to digital converter, which is shown here. So, focus on the diagram. The first element, that is the sampler. The sampler extracts the sample values of the input signal at the sampling instance. The output of the sampler is the discrete time signal with continuous amplitude. The signal is applied to a quantizer which converts this continuous amplitude into finite number of sample values, each of which is represented by a digital word of finite word length. That is, the output of the sampler is fed as the input of the quantizer. Now, quantization is the process by which the amplitude of each sample of a signal is rounded off to the nearest permissible level. That is, the conversion of a discrete time continuous amplitude signal into a discrete time discrete valued signal. This is the only process in the analog to digital conversion where error can occur. The error is the difference between the value of the analog input and the analog equivalent of the digital representation. This can be reduced if there are more permissible levels and the width of these quantization levels is small. The final state of the analog to digital conversion is the encoding. The encoder assigns a digital word to each quantized sample. This is done by representing each of the permissible levels by a digital word of fixed word length. Now, regarding the signal reconstruction. Any signal can be faithfully reconstructed from its sample by separating the spectrum of the signal from that of the harmonics. This is achieved by filtering the sample signal using a low pass filter with suitable frequency conditions. So I hope this is clear to you. And this is actually just an overview of the digital signal processing. There are so much more to say about this process to make this in detail. So please be free to include your suggestions in your comment box, and hope you enjoyed this. Thank you.